Interpreting expressions. This is basically understanding what each term and an expression means. Now, let me just make sure we understand what a term is, so I'll write an expression down. Let's say, what year were y'all born?
2002.
I heard a lot of 02, so I'm going to go with that one. 2002. So, if I wanted to find out how old y'all were, I would take X, which would be the year today, whenever I do this, right? So I will let X represent the year currently. So the reason I would say X instead of just the year, because I want this to work every year, not just the year that I am right now. So for this, X is to be interpreted as the year currently. Now if I said, what was your age in 2014? Then I would plug in 2014 because that was the year currently with the question that I was asking. So I want you to do this when you have equations or when you make equations. I would first want you to set up each variable. So if there's an X, you just set up an X and you say, okay, what is X? X is the year currently, or X is equal to the year currently. Remember, is and equals are the exact same thing. Okay? Math language and English language go kind of hand in hand. There. Okay? X is the year currently. So just define your variable. Now, normally you'll see something in the form of y equals mx plus b. That's probably how y'all guys have seen a lot of your formulas. I want to make sure that you understand what X is in most formulas. X is the input, okay? The input. In other words, it is the independent variable. Anybody still singing that song to spell that correctly? I-N-D-E, no? Okay, I'm old. All right, input and independent are the exact same thing. So if I say input or if I say independent, they are completely replaceable with each other. So don't think that they are separate entities. They are exactly the same. Okay? Therefore, if X is the input and dependent, then Y must be the dependent variable and it must be the output. So Y is the output and it's dependent. So every equation you have will have some kind of input value and some kind of output value. Here, this equation would equal some other number, and y would be your age. Y is age. See? So X here is my input. I'm going to input the year, and as a result, when I do the calculation, I'm going to get the output, which is your age. Alright, so that's kind of two separate things. So let's get into actually going from the book here. I've defined for you dependent and independent variables. The constants, y'all guys already know constants are just regular numbers, okay? And the variables are the letters involved in those numbers. So let's go into just reading a problem. So here's your equation. It's 8.5h plus 10. So you can develop lots of stories from this, but I want you to think about what, without reading from your book yet, what do you think H might stand for? Hours. It can stand for anything, yes, but say that again? Hallways. 8.5 hallways. I don't know if that one makes sense. 8.5 horses. Maybe if we were talking about how much food to give them, maybe it's 8.5 cups or something, okay? Half a pony. Yeah. Anyways, so H could stand for a multitude of things. It's important that we define what H is. I think it's going to be hours because 8.5 sounds like a pay rate to me. Let's see what this says. Suppose the babysitter, so we're probably already leaning towards the hours thing. Suppose the babysitter charges a $10 fee for each job plus a 15-hour of babysitting. So the expression here, H represents what? 15 hours. So So H is hours. I need to understand what it is. It's fairly obvious here because they use the letter H. Now if I put an X there, that's going to leave you like, what does that mean, right? So try to use variables that make sense with the problem that you're taking. Try not to use O for oranges because it looks just like zero. Okay? Use letters that make sense, but also ones that you can differentiate between letters and numbers. All right, so moving on. It says that it gives the total for each job that lasts H number of hours. So the variable H stands for hours and can take on different values according to how many hours each job lasts. The coefficient, what is the coefficient? I heard somebody say it. 8.5. Why 8.5, Hannah? Because it's in front of the variable. Okay, so 8.5 is the coefficient. It's the thing in front of the variable. What?
I would have got yesterday if you had told me that.
You didn't ask. All right, so there's your coefficient. Now let's just quickly label the constants. The constants are just numbers, right? So obviously 8.5 is a number. What's the other number involved in this equation? 10. So 8.5 and 10 are the constants. The variable, I'm going to abbreviate that one. The variable is H. Fairly obvious, right? So there you go. We have our coefficient, which is the thing in front of the variable. We have the variable itself, and then we have all the constants listed. So we can easily see everything that's involved in this equation and by its label. All right, so moving on. If the job lasts, let's see, did you say 15? Did you make up that number, Tice, or did you see that somewhere?
No, you read it in the question.
Okay. So he said 15 hours.
Well, you said that the babysitter
Charges 8.5 or $8.50 per hour. Let's just run this scenario that Tice accidentally made up. So he said she worked 15 hours. So, okay, H equals 15. What do I do to solve this problem?
multiply and add.
I'm going to multiply then add, yes, but what do I got to do with this H?
They can put 15 in parentheses.
I got to put 15 in parentheses. That's called, anybody remember the word for that? Okay, if you're sitting the bench and your coach puts you in, that's a substitute. So this is a substitution. Put me in the game, coach. So we have 15 multiplied by 8.5. Go. I'm not sure what that is off the top of my head, to be honest.
It is 147.5.
127.5. I don't know any babysitters getting paid this. Just want to throw that out there. Plus a flat $10 rate equals 137.5. Why would I not accept your answer like this?
That's crazy.
$0.50.
$0.50. Now, while this is technically correct, let me just show you what it looks like. While that is technically correct, it is not correct because nobody is going to give you a total without that second decimal place, right? So go ahead and write in that too. Take into context what you are working with. Now, that is crazy to make in a day for a babysitter. If you are making that as a babysitter, oorah to you, you go girl. Or boy. Whoever you are, go you. Okay, I would love to make that in a day babysitting. If somebody paid me to watch my son for 8.5, well, I watch him 24 hours a day. So, if I got paid 24 hours a day, this would be sweet.
Well, you know what to do right now.
I was watching him this morning. He made me cry. Anyways, yeah, he was very sad that I left this morning. All right.
You should have brought him with you.
I would have if it was legal, but yeah. Anyways, moving on. We're gonna go to the next page. Go to the connecting. Who wants to read that one? All right. Jorge has 5 male turtles and 2 breeding pairs of rabbits. A weird combination.
George.
Anything with a J, O-R-G-E, is Jorge. Jorge, George. Yeah, don't try to go up to a Spanish person named Jesus and say Jesus. They might get upset with you.
What if I say Jesus?
No, that's wrong too. I think technically that's Kanye West. I don't know that for sure, but he thinks he is. All right. Jorge has 5 male turtles. I'm just going to write down everything that I see that might be useful. I don't particularly know why, but I'm going to round up. Okay? And he has 2 pairs, so 2 pairs, probably meaning a male and a female, right? 2 pairs of rabbits, breeding rabbits. Rabbits. Okay, the total number of animals that George has after M months, so M stands for months. After purchasing rabbits can be approximated using this expression. Now he says 4 multiplied by 2 to the M power plus 5. Okay, why do you think the plus 5 is there? Because he has 5 male turtles, right? Where do you think that 4 comes from?
The 4 rabbits.
The 2 pairs, which ultimately means 4 rabbits, right? Okay, so let's keep moving on. Has another factor, we're going to explain these things, right? So here's the question. What does each part of the expression mean in this situation? So we already established 4 stands for the number of initial rabbits. M stood for months, we wrote that down. We had 5 male turtles. So we need to figure out what this stands for. What does the 2 stand for, do you think? Anybody know anything about rabbits? Oh,
2 years.
2 years. I doubt that's part of the calculation, because remember, this is equaling the total number of animals, right?
It's 2 and a litter.
Okay, I think that's closer.
Maybe for each
You spelled total wrong.
Thank you.
maybe for each count, the letter N to the call.
Okay, so Hannah says that the number of rabbits they will produce, okay, the month is M, yes, but the total numbers produced by that rabbit will be multiplied, because let me show you what this looks like after month, let's say 3. So I'm going to rewrite this equation. 4 multiplied by 2 to the 3rd power plus 5. Now if you let rabbits just breed wild, you're going to end up with an immense amount of rabbits, because they can breed every single month. Okay? They're literally always in heat. So they can have little baby rabbits, little cute adorable things, very quickly. Okay? They breed pretty much the same way that mice do, very quickly. So let's look at this. After 3 months, we have 4 initial rabbits. We think that for every rabbit there's going to be 2 more rabbits, and for every month they can reproduce again. So 2 to the 3rd is what? 8. Plus my 5 turtles. So 4 times 8 is 4 times 8, people. 32, thank you. Plus 5, 37. So he will have 37 animals in 3 months, right? So if the question says how many animals will he have in a year, this is going to go quickly. This is going to go very quickly, because look, from the original, let's think about how many animals he had originally. He had 5 turtles and how many rabbits? 4. So originally he had how many animals, people? 9. Right? So he had 9. In 3 months he has 37. So let's see how many he's going to have in a year. What do I plug in for M? 12. So 4 times 2 to the 12th, somebody find that for me, plus 5 equals, you will be surprised by this answer, I hope. I need somebody to be doing that calculation, 2 to 12. If you're typing in 2 times 2 12 times, you are doing it the hard way. Let me show you how to do it on a calculator if you don't know how. Press 2. Here's a little caret thing right here underneath, clear, to the 12th power, 4,096. So 4,096 is what we get for 2 to the 12th. Now we have to multiply that by 4. We're doing an order of operations here if you haven't quite figured that part out yet. What do you get? What do you get? I think you might be wrong. What'd you say? 4098? Yeah, no, that's a smaller number than we should have. That number makes sense. 16,000 what? 384. Holy moly. Plus 5 little baby turtles. So we get 16,389. hope at some point he goes, maybe I should separate these guys. Right?
I think that's an understatement, because they don't just have in 5 terms.
No, no.
That's why the other thing is
Like no dogs in there.
So, I have an argument over here. Hannah says, I think that actually might be an understatement, because they don't just have 2.
Lord.
So, wouldn't it be scary to think that you could potentially have 16,384 rabbits, and that's an understatement?
That's a lot. It's hard.
But you also got to think about half of those are going to be male and they can't reproduce. So there's 6 to 8. We have an expert saying 6 to 8.
I had rabbits. Yeah, I had rabbits.
All right, let's move on. Next page, ladies and gentlemen. This one's interesting. Takesha is driving with her to her grandmother's house. That is a guy? I may have mispronounced that name. Takashi? Maybe it's Takashi. That makes a lot more sense for the he part of things. All right. Takashi is driving to his grandmother's house. He is driving at a constant rate of speed and will not make any stops along the way. Takashi's distance in miles from his grandmother's house, H being in hours, so I'm going to write that down already. H stands for hours. After leaving can be described in this equation. D equals 125 being the what? Miles from grandma's house. So what does each part of this equation mean for this situation? So we already established that H is hours. What do you think D stands for? Distance from what? Or to what?
From the Kashi's house to grandmother.
Well then, what does 125 stand for?
His rate of speed.
He's going 125 miles an hour?
Yes.
He's going how fast? He's going 55 miles an hour. So, 55 stands for his rate. So what does 125 stand for? His distance from where to where? From his house to his grandma's house. Therefore, D cannot stand for the distance from his house to his grandma's because that's 125. D makes sense in this equation, so think about what it might be. It is a distance, but it is not the distance from his grandma's house to his house. Let's think about what's going to happen. Okay, let's just work up one of them. Let's say he's traveled for an hour, 1 hour. So we're going to plug in 55 times 1. So he goes from 125 miles minus the 55 he's already traveled. What do we have left? $70. So D here would have been 70. What does 70 represent? Distance, how much he has left. So D stands for distance left to grandma's, right? So it's distance left to grandma's is what that one is, right? So D stands for distance left. We discussed 125 was the total number of miles and 55 was the miles per hour. H obviously standing for hours. They told us that. So we've identified everything in this equation. Here's the question. How long is it going to take him to get to grandma's house?
About 2.5 hours.
He says about 2.5 hours. Hours. What if I want an exact answer? What will the distance be? What will D stand for when we're at grandma's house? It'll be 0 because we're there, right? There's 0 miles to grandma's house. So let's play. If D is 0 because we're at grandma's house, and we had 125 miles to travel, and we were going 55 miles an hour the whole way, can I solve this problem? Go ahead. What do I do first?
You divide.
Don't want to divide first. I want to make my life easy, not hard here. Oh, we don't know. All right, here we go. You actually still use order of operations. But here's the crazy part about it. You use it backwards. If you are solving for a variable, if you are isolating a variable, you use order of operations backwards. So I look for addition and subtraction. Do you see some addition and subtraction? Yeah, it's right here, right? But I don't want to deal with moving this whole thing. I can if we want to. I need to move that to the other side so that I can isolate my variable. I'm trying to get the h by itself. So, what do you want to do? I need to get h by itself. I heard somebody say move 125. That's fine. May not be the method everybody chose, but that is fine. How am I going to move positive 125? There's no exponent, sir. That is a variable. You want it in parentheses? I can put it in parentheses. There you go. Okay, I heard the right answer. How do I do it? Move 125. How am I going to move it? I can't do it by magic. Right, I have to subtract it, in other words, right? So what I do to one side, I must do to the other side. It's like giving candy. If you have little siblings, you got more than one, you give one of them a candy bar, the other one's going to start crying. So, if you are the little sibling, you started crying. And then you probably told your mommy. And your mommy got you a candy bar. So we have to be fair, is basically the moral of that story. We have to be fair. So if I subtract 125 to this side, I have to subtract 125 to this side. So what's good about this is I don't have to do any work there. Those two just cancel out. 125 minus 125 gives me 0. So I'm not even going to write down the 0. I'm just going to leave it alone. However, 0 minus 125 leaves me a negative 125. And then this little piece right here that I had, I'm just going to drag it down because I haven't done anything with it. I just have to drag it down. Now, how do I get rid of a multiply by a negative 55? Because I have to get h by itself, right? I need this guy by itself. And right now he's being multiplied by negative 55. How do you get rid of multiplication? Division. So if I'm going to do division to one side, I've got to do it to the other. I'm going to get rid of negative 55. So nice thing about doing that is those cancel. But what I do to one side, I must do to the other. Nice here, those negatives cancel. I don't know 125 divided by 55. What is it?
It's 2.272727.
So 2.27 repeating? Repeat end over that thing. Now if I had a label on this, I would say 2.27 hours. Now most people aren't going to tell you 2.27 hours, right? They're going to tell you 2 hours and minutes, right? So we would need to figure out what is 2.27 repeating in minutes. Does anybody know how to do that? What is 0.27 of 60, right? Because remember, one whole unit stands for an hour. So you need to know 0.27 of 60. So here you go, 0.27 of meaning multiply by 60. And it's about 16.2 minutes. Okay? Well, it's going to be a little bit more than that because it's 0.27 repeating, right? So it's about 16, it'd be 2 hours and about 16 minutes. So for the sake of this answer, I'm just going to write 2.27 repeating so I have an exact answer, hours. And there it is. Okay? However, most of the time they will tell you what unit of measure they want you to put it in. They say write it down in hours and minutes, write it down in minutes, or just write it down in hours. Any questions about it? All right. All these equations that we've been seeing, these ones with one variable down here, these are linear. They don't have a power. Okay? Anything without a power, meaning there's no exponent on your variable, that is going to be linear. So this y equals mx plus b, that one was linear. This 8.5h plus 10, that was linear. This one right here, the variable is a power, so that's not linear. Okay? Linear meaning line. Okay? So anytime you hear the word linear, think line here. Okay? Let's go to the next set of problems. Example B. It says Jenny pulled the stopper out of the sink. The amount of water in gallons remaining in the sink for each minute followed can be modeled by this representation. 17 minus 5m. So, let's think about this. This must be a pretty big sink, first of all. We need to interpret the parts of the equation. 17 stands for what, do you think? Gallons, but gallons where? In the sink. So, gallons to begin with, gallons in the sink. So what do you think this minus 5 is per minute? Because we already decided that m was minute, right? So it's losing at 5 gallons a minute. So what would I call that? It's rate, right? So drain rate, All right, so it's going at 5 gallons per minute down. So we've established what each piece of this means. This is the initial amount of gallons in the sink. This is the drain rate because it's negative, it's coming out. And M stands for the number of minutes that it has been draining, right? So we've interpreted each of the parts. Now, let's decide how much time it's going to take to get this thing all drained out. So, I want to make it equals here. Remaining water, right? I'm going to put R over here. And I'll just let R stand for remaining water. So there's my R, remaining water. Sorry, you want my better R? There you go. Here's your R. So that stands for your remaining amounts of water. Now, how much remaining water will there be when the sink is empty? Come on, guys. 0, right? None. None, not a 0. What if, this is a bad example because I had to do it to Liam last night. He wants to take a bath in a tub that's half full. But when you wash his hair, you don't want him in a tub that's half full, he'll drown. So, we let out the water till it's about this much left, then he lays down and we wash his hair. So, we don't want to drain it all out. We wanted to leave, it's probably got like 3 or 4 gallons in it. Okay? So, let's run this as if I wanted to leave 3 or 4 gallons in it. So, let's run it as 4. Okay? So, the remaining gallons is 4. I want to leave 4 gallons in it. So, I just rewrite the rest of that equation, 17 minus 5m. And now I need to solve. I want to know how many minutes I need to let water out of this thing to have exactly 4 gallons because I'm weird like that and I need precision. So, here we go. What do I do first? Minus 17 on both sides. I agree. This is what I will probably end up telling you multiple times. Get all of the things with variables on one side, get everything that doesn't on the other. Okay? So, variables on one side, everything else on the other. So, this is part of the everything else, so we're going to put it on the other side. Of course, those cancel. I'm left with negative 5m on the left. Now, this is going to equal 4 minus 17. 4 minus 17 is negative 13. Good? All right, next part. I have a multiplication problem. How do I get rid of multiplication? Division. Do it on both sides. Negative 5, negative 5. That one cancels, of course. And the equals. These negatives will cancel, of course, because you don't have a negative number of minutes, right? If I got a negative answer here, what would I know? Got a negative answer for my number of minutes, what would I know? Oh, come on, guys. You get a negative answer for minutes, you're wrong. Go back and figure out what you did right or wrong in that case. Okay, he said 2.6 was 13 divided by 5. Exactly? Okay, 2.6 minutes. A little over 2.5, right? Now, what if I want to find out how many seconds 0.6 was? I just told you how to do this on minutes a second ago. How many? 0.6 times 60. So I take 0.6, I multiply by 60, and it's going to take 36 seconds. Okay? So it's going to take me 2 minutes and 36 seconds to drain out how much water I need, which just ends up being 13 gallons. Any questions about it? Comments, concerns? Okay. Your practice is what's next. Take a look at practice real quick. We're just going to talk about them a little bit. I'm going to tell you